Okay, so hello everyone. Let's start second tutorial. So this tutorial will consist those topics, that is it is basis, matrix representation, coordinates, and computations. Computations based on those topics mainly. So those are the topic of our interest. So is it audible to everyone?
Yes, sir.
Okay, thanks. So sometimes you type something on chat and actually I have not noticed those things. Previous day yes, someone has typed something but I have not seen. So maybe you can speak if you want to say something or if you are asking something. Okay. So here three three rows are given. One is 1 minus 1 0 1 2. Then second is alpha 2, this row, and fourth row is this. Now those are row 1 2 3 4. So we can form a 4 by 4 matrix out of those rows. Now the question is which of the following belongs to the row space? So let us see how can we solve those kind of problems. So let us form the row matrix. So the matrix is given as R1, R2, R3, R4. So those are four rows. So we can write as so sorry, here the notation is alpha 1. So alpha 1, alpha 2, third row is alpha 3, fourth is alpha 4. So this will be 1 minus 1 0 1 2, then 2 minus 2 2 4 6, minus 3 3 0 minus 2 minus 6, 1 minus 1 minus 2 1 0. So we have four rows and let us do some row operations, elementary row operations. So first thing is to cancel. Will what will we do? Actually, we'll perform elementary row operations and reduce the matrix A to its row echelon form R. This is the process to solve those kind of problems. So let us first try to reduce in row echelon form. Okay. So reduce row echelon form. So first to make it vanish, those 2 minus 3 and 1 will perform those operations. For example, R2, second row minus 2 times R1. Similarly, third row plus 3 times R1. And fourth row will be R4 minus R1. So if you apply those kind of operations, first row will be unchanged, 1 minus 1, 0, 1, 2. Second row, first element now leading entry will be 0. And after that, it is again 0, minus 2 plus 2, right? Minus 2 plus 2, which is 0. This is 2 minus 0, which is 2. Then 4 minus 2, it is 2. 6 minus 2 times 2 means 4, which will be 2. And similarly, second thing will be multiply this with 3 and add with this row. Third row. So it will be 0. Now again 0. After that, it is also 0. Then minus 2 plus 3, which is 1, minus 6 plus 6, which is again 0. And after that, what is the next thing? It will be 0, then 0 again, minus 2, minus 0, which is minus 2, 1, minus 1, which is 0, 0 minus 2, it is minus 2. Okay. So now, again perform row operations. What will be the next step? So everything is right. Correct, right? Okay. So next step will be, you can see that if we add R4, no, this is not right. So what we can do, make the leading entry 1. So the operation need to be performed, which is half of R2. So everything is unchanged, and the second row, so first row is unchanged, the second row will be 0 0 1 1 1. Third row, and only second row is changed, except those everything is same. Now what we can do, you can see that if we subtract this, so we can, since -2 is also there, this is
Sir,
the
add.
entry. Hello.
Sir, add R2 and R5.
Yes.
Replace R5 by R2 plus R5.
Yes. So we can change R4 to R4 plus 2 times R2, right? So it is 1 minus 1 0 1 2 0 0 1 1 1. Everything is unchanged, 1 0. But if we multiply 2 with this row and add with the last row, it will become 0 0. Then it is 0. This will also be 0. But the next thing will be 2, right? Okay. So after this, what can be done? So you can see that
Sir,
here,
the last one will become 0 0.
yes. So if you perform the operation R4 minus 2 times R3, then last row will be 0 0 0 0 0. And similarly, if you perform second row, if you subtract third, then second row will become 0 0 1 0 1, and this is unchanged, 0 0 0 1 0. Now similarly, again R1 minus R3, it will give 1 minus 1 0 0 2, right? So the next, is there, can you reduce further? So you cannot reduce now, because those leading entries are in ascending order. So this is the leading entry of first row, this is leading entry of the second row, this is leading entry, and all are 1, and it it is in the ascending order. Below this leading one, those are 0, right? So you cannot reduce it further. Below and above 1 also, you can see that wherever there is leading 1, the other things are 0 in that column. So this is the row reduced echelon form, RREF. So we get the row reduced echelon form, RREF. Now can you see which of the following is in the row space from here? So 10222, is it there? Can you write 10222 as combination of those rows?
No,
There
sir.
are 3 different rows, 3 linearly independent rows. This is R1, this is R2, and this is R3. So which can be written in terms of this? So let us see. For example, if you try this first thing, 10222, first option, if you try with the first option, you can see that, so only this row contain 1 in the first place. Therefore, it should be 1 times this row, 1 times R1. Now, similarly, by similar reason, only uh, second row will contains 1 at third place. Therefore, this third place, to make it 2, we need to add in this way 2 times R2. Okay, and this is also for third row. It contains 1 at fourth place, right? So this fourth place is also 2, so 2 times R3. So if this equality is satisfied, then A will be an answer. So let us check what is the value of R1 plus 2 times R2 plus 2 times R3. If you put, so it will be 1, and this 2 is also there. So what is the middle thing? It will be minus 1, right? And similarly, 2 times, what is the last entry? It is R1, this thing, plus 2 times R2, which will be again 2, and 2 times R3, which is 0. So it will be 4. So you can see those two are not equal. Therefore, this 10222, this thing does not belongs to the row space, because linear combination, if this belongs to row space, this should be the linear combination, but those two things are not matches, right? So this is not an answer, but what will be an answer? Can you figure it out? So you can see that if you try the second thing, maybe we need some space. So second thing is 1 minus 1 2 to 4. So option B, 1 minus 1 2 to 4. Can you write it as linear combination of those three rows? So let us see. So again, by the same reason, you can see those are the pivot entries, right? Let us collect by anything this, or
Sir,
maybe
right, sir. So right first row as it is plus 2 times second row plus 2 times third row.
yes. So it must satisfy the. So first place is also, again I am coloring those first, first thing, fourth, third place, and fourth place. So from here you can see that if there is such a combination, then it should be 1 times R1, then third also 1, third is here 2, so it is 2 times R2, and here
Plus
this
2
third
times
row
R.
contains 1, and here means third row contains 1 in fourth place, but here fourth place is 2, so it should be 2 times R3. So if you add those combinations, so let us add those three combinations, then you can check that it is 1, then minus 1, after that it is 2 times R2, which is again 2, then 2 times, again it will be 2, and 2 times R3 is 0, it is 0, and here it is 2 times 1, which is 2, and 2, so 2 plus 2 means 4. So you can see the second equation is holding, that is second thing you can write this. So
Sir,
1
1
minus
minus
1,
1 2 2 4, sir.
yes,
Sir, there is missing
sorry,
2.
this is actually equality, this is actually equality, but this is not equal to this, because if this is equal to this should satisfy.
Sir, the last, sir, Victor. 1 minus 1 2 2 4,
Oh,
sir.
sorry, I have not written one element, it will be 2 to 4. Okay, thank you. So from here you can see that option B is the correct answer, right? Option B is the correct answer. Is there any doubt in this question? So what is the process of solving this problem? First, reduce it to row reduced echelon form. Now compare those pivot elements. So can you mix linear combinations in such a way so that this holds? That is, you can write this element here. For example, 10222. Can you write it as a linear combination of these three rows. Okay, if this computation gives the same value, then it is true. Otherwise, it will be incorrect. For example, here A is false, but for B it actually satisfies. So let us do the next question. Again, the same question. Now, which of the following set can be considered as basis of row space of A? So, which of the following can be considered? So, you can see that basis consists three row thing. That is this row 1, row 2, and this row 3. So, base, because from here you can see that what is the rank of this matrix. You know that rank of A, it is same
3.
as rank of row reduced echelon form.
Yes,
But
sir.
for this row reduced echelon form, there are 3 pivots. So rank will be 3, right? So those options are not true, because for this there are 2 linearly independent vector. For this there is 2 linearly independent vector. So let us see which will be true. So here you can see 1 minus 1 0 0 2. It is present in this example 1 minus 1 0 0 2. Next is 0 0 1 0 1. But 0 0 1 2 1. Here 0 0 1 0 1 is present. So maybe this can be true. But let us check. And the last entry is 0 0 1 0 0 0 1 0, which is, so the answer is D. Because R1 is 1 minus 1 0 0 2, R2 is 0 0 1 0 1, and R3 is 0 0 1 0. So from here you can conclude that option D is the correct answer. Okay, and it is also true that B is false. Why B is false? Because can you write 0 0, since those are forming the same row space, if it is a basis, then it should also form the same row space. That is, row space of those three things should be same as row space of those three things. But let us see that 0 0 1 2 1, this is not in the row space formed by those three. Why this is true? Because if it is true, then you can write from again comparing those leading entries, you can see that it should be same as R2, and here it is 1, so it is 2 times R3. But is it true? So R2 plus 2 times R3, this will give you 0 0 1 2, and
Sir, it is true, sir.
it is true. Yes, it is true. Then what is the problem? So this element
Last,
belongs to uh, R2 plus 2 times R3, 1 2
sir,
1.
last element, sir. Last element. 0001, sir.
Okay, so last element, yes. So last element is 0 0 0 0
1.
1. So it should be also linear combination of those three rows. So is it possible? Can you see? So here leading entry is 1, leading entry is 0 here, so it should be 0 times R1. Here the
Yes, sir.
leading entry is 1, but you can see leading entry is 0, so it should be 0 times R2. And here it is 1, but it is 0, so again 0 times R3. So though this is 0,
0.
but this is not 0 vector. So these two are not equal. Therefore, C is also B is also incorrect. Is it clear why this is the only answer?
Yes,
Okay.
sir.
Next. So problem number 3. You need to find coordinate matrix of this vector b1 minus b1, this vector. So you need to find coordinate. What is the meaning of coordinate? So b1 minus b1, b3, b4, 2b1 plus b3. The coordinate will be something like this. Coordinate matrix. The coordinate matrix of this in row space. So this can be written as okay.
So what are B1, B2?
So initially the rows were alpha 1, alpha 2, alpha 3, right? So you need to write in terms of those three things. Alpha 1, there are four vectors. So you need to write it as linear combination of those four vectors. Alpha 1, alpha 2, alpha 3, alpha 4. Mm.
So what are B1, B3, B4?
Yes, the coordinate of this in row space of A. Okay, so here the basis actually obtained from Q2. So Q2 is the basis. So here the basis were this 1 minus 1, the last option, right? So you write write it, sorry. So let us denote it by beta 1, this is by beta 2, this is by beta 3. So you can see that beta, can you write it as something like this? Some x1 times beta 1 plus x2 times beta 2 plus x3 times beta 3. If you can write it as this combination, then the answer will be x1 comma x2 comma x3. So let us see if we can write. So again, see that what was initial beta. Beta was like beta 1 was 1 minus 1 0 0 1 minus 1 0 0 2. Beta 2 was 0 0 1 0 1, and beta 3 was 0 0 0 1 0 0 0 0 1 0, right? So can you write this as linear combination of those three things? Can you write? So you can see first entry should be b1, therefore it is b1 times this. Again here third entry is 1 there, so but third entry you can notice that third entry is b3, so it should be b3 times this. And again here you can see it contains 1 at fourth place, so fourth place here it is b4, so it should be b4 times. So if it can be written as linear combination of those things, then it must satisfy this relation. But is it true? You can easily check. Then if those are satisfied, then the second entry will be minus b1, which is true, and fifth entry it is 2 times b1, 2b1 plus b3, which is again true, right? Therefore the answer is, here you can see x1 is b1, x2 x2 times beta 2, this was our beta 2, so it is b3, and x3 times beta 3, which is b4 times 1, so it is b4. Therefore the correct option will be this, b1 comma b3 comma b4. Is it clear? Just same thing, that is you need to compare those leading one. Leading one will tell you what will be the answer. Just compare, make combination of those leading one so that this satisfies. If this is true, then you can make such combination. If it is not true, you cannot produce such combination. Okay. So let us see the question number 4.
Sir,
Yes.
sir, option B is incorrect.
Option B is incorrect. Yes, option B is not possible because you can see that the combination b1 comma b2, if you write for option B, if you write b1 times beta 1, so there are three basis elements, so there should be another coordinate, right, which is not there.
Sir,
So
1
it is
cross 3 matrix, sir.
yes,
Coordinate order of the coordinate matrix should be 1 cross 3.
yes, coordinate order of this coordinate will be 1 cross 3.
Okay.
True.
That's clear, sir.
Yes, actually the coordinates should be written as transpose of this thing, because we write coordinate in a column, so it should be actually the correct answer will be like this, transpose of this b1 b3 b4.
Yes, sir.
Okay, nice. Yes, this should be the right answer. So the row space of A which satisfies the, okay, so the coordinate matrix should be transpose of those things. Okay, nice. So here question number 1. Question number 4, again consider the matrix given in question number 1 A. Then which of the following sets can be considered as basis for the solution space Ax equal to 0? So you know that if x satisfies the condition Ax equal to 0, then it is if and only if it also satisfies Rx equal to 0. Where what is Rx? Rx means row reduced echelon form. Right? If Ax equal to 0, then Rx should also satisfy the same. That is R times X will be 0. So let us copy what was that row reduced echelon form. So you can see in this question, row reduced echelon form was this. So copying. So this is our R. R equal to this matrix. Now, so maybe some color. You can see that this and these two rows are free rows because it does not contain any pivot element, right? Therefore, pivot means that non-zero leading entry, which is 1. Okay, so this is the pivot in row column 1, this is in column 2, this is in column 3. The leading one appearing in each rows, those are called pivot. So corresponding pivot column are those R1, R3 and R4. C1, C3 and C4. Those columns are pivot columns, except those are actually free columns. So if something is solution, so you can see that rank of this matrix is 3. So rank of the solution space corresponding to this X equal to 0, rank of solution space or null space, whatever you say, it will be, so it is, you can see this is 4
P
by
minus
5
2.
matrix, so it is
5
5
minus
minus 3, which is 2. You know, right? For m by n matrix, if rank
yes,
is n, rank is R, then null
N
space,
minus R.
dimension of null space, it is n minus R, dimension of null space. Or okay, dimension is not introduced, but Let us write. So the main thing is that there are only two linearly independent solutions. So here you can see that second and fifth column, here you can choose anything. So I will choose those two things. Second and fifth column is 1 0 or 0 1, and all the other three things will be automatically obtained from this choice. 1 0 choice will give you a solution, and 0 1 choice will give you another linearly independent solution, right? So if you put 1 0, you can see the fourth equation. What is the fourth equation? Fourth, if you just multiply r times x, the fourth equation will be 0 x1 0 x2, that is corresponding to this row, plus 0 x3 1 times x4 plus 0 times x5, which is 0. So from here you can see that this is same as saying x4 equal to 0. Therefore fourth entry will be 0 in this case. But what is fourth entry in this case? If you choose 1, again you will get the same answer, right? So this is 0. Next, again if you use the third row, for the third row you get this combination, that is x3 plus x5 equal to 0, right? But here if you have chosen x5 to be 0, so if you choose x5 to be 0, then x3 will be 0. But here you choose x5 is 1, you have chosen that, therefore it will be -1, right? Now let us use the first row. So from first row we are getting x1 minus x2 plus 2 times x5, which is 0. So if you put all those choices here, for the first thing it is, second thing is 1. So you are getting x1 minus 1 plus 0 equal to 0. So you are getting 1 in this case. And for another case, if you put those rest entries, then you are getting x1 uh, minus 0 plus 2 times x5. x5 is 1, right? So it is plus 2 equal to 0. So it will become -2. So is it matching with any answer? Maybe this answer 11001. No, 11. This is not 11000. This is matching. Then 11000. This is matching, and -20 -101. So you can see option B is the correct answer. Option B. Is it clear?
Sir, here, sir, x2 and x5 are free variables, sir.
x2 and x5 is free variable, right?
So we can choose x2 and x5 as 0.
Yes. So free variable means you can choose x2 and x5. You can see what we have chosen. Let us color it white. So there are two linearly independent solutions. So we'll choose x2 and x5 as this 1, 0 or 0, 1. So first case I have chosen 1, 0, and for the second thing I have chosen 0, 1. So this will give you a solution. This will give you another linearly independent solution.
Sir, 1, 0, sir.
Yes.
How are you, sir? How are you choosing 1, 0, sir?
Yes. Since those are free columns, you can
Yes.
choose anything in this case.
Sir, 1,
Any
0, 0,
combination
0,
will
sir.
give you a solution. So that's why I'm choosing 1, 0 here, and another choice will be 0, 1. You can choose any other combination. For example, instead of 1, 0, you can choose 2, 3 and 3, 4. Those things will also give you, for different independent choice, this will give you two different linearly independent solutions. Right? So easiest independence thing will be 1 0 0 1. Those are linearly independent because those are corresponding to identities, columns of identities.
Yes, sir.
So that's why I have chosen those. You can choose any, whatever your favorite numbers, favorite columns, but those should be linearly independent. And so though these two things are giving solutions, but if those are not there, then we need to check if linear combination of those things gives you those, because any other choice will give you other solutions. So you need to check again something. Some work is need to be done. Okay. So let
So
us.
similarly, we can find the range space.
Similarly, you can find range space.
Yes.
Yes. So let me say, you since you have mentioned, nice. So the range space, this will be linear combination. Sorry, this is actually null space or solution space, space of all solutions. So the all solutions means it will satisfy the relation. So those are actually you can see that those are actually transpose, right? Because it is column vector, but it is row vector. That's why it is satisfying. So null space can be written as linear combination of those two things. So any other solution, whatever your favorite solution, it should satisfy this relation. That is, it will be alpha times maybe some constant times first one 1 1 0 0 0 plus some another constant time minus 2 0 minus 1 0 1. So any solution, so this is where c1 comma c2 are any real number. So if you choose any two real numbers, you will get the whole solutions. That is, any solution can be obtained as linear combination of those two things. So any solution will look like c1 minus 2c2. Then the second one will be c1 plus 0c2. Then 0c1 minus c2. And again 0c1 0. So it will be 0. And last entry will be c2. Oh, I don't have space. Maybe it is c2. Okay. So any solution will look like this, where c1 c2 belongs to R. Is it clear? This is the null space, you can see. And yes, so solution space can be obtained from this. Let us see question number 5. Here, you are considering the same matrix A given in question number 1, and X is these 5 tuples, Y is these 4 tuples. You need to find then the system X equal to Y has a solution. So for which condition X equal to Y has a solution?
Sir, please show the matrix A.
Yes,
Matrix A, sir. Please show the matrix A.
this.
Matrix A, sir. Can you show the matrix A?
Okay. Let us again write the matrix A. That was the matrix A. So the matrix A was this matrix. So I need So the question is like this: a is there, and x will be of this form x1, x2, x3, x4, x5. You can see this is 4 by 5 matrix. So the answer of this will be some y1, y2, y3, y4. Now, for which conditions of those x1 up to x5 there is a solution. So let us again apply those things. So what will you do? You
Sir,
you
first
write.
form augmented matrix.
Yes, right. You form the augmented matrix corresponding to this. So the augmented matrix will be this
A plus y, a comma, मतलब
a comma
y.
y1, y2, y3, y4. Now again we'll perform those previous row operations, right? So if you see the what are the previous row operations, so if you perform previous row operations, then it will a becomes the augmented matrix like this. Sorry, a becomes the row reduced echelon from this. A becomes this. But the question is, what will be the form of the next thing? The additional extra row. What is the. So if you again perform the same operations, so let us perform those operations. So let me copy those things. This is let me add an extra page. So first one will be like apply these operations, right? Apply these operations. So I am not interested what is happening here, but the main interesting thing is what is happening on those y1, y2, y3, y4, because we have already computed those things. So I am not computing again, but second it will be y1. The second thing is r2 minus 2r1, so it is y2 minus 2 times r1 means 2 times the y1. Then r3 there is y3 plus 3 times y1, and again y4 minus y1. Okay, next again copy those operations. Half of r2, r4 plus 2r2, half of r2, then it is something comma y1, y2 minus half of y2 minus y1, and other things are unchanged. What is the next operation? Next operation, it is r4 plus 2r1, right? R4 plus 2r1 was that operation. Yes, and also copy this thing. If you apply r4 plus 2r1, what are you getting? It is y1, second thing is y2 minus y1, y3 plus 3y1. Then it is, let us compute here, y4 minus y1. This is r4 plus 2 times r1, 2 times y1. So here this is same as, you can see that this is same as, this is equal to y4 plus y1, right? Now the next operation will be like this. So if you apply those operations, then this will become, so I am not doing those things. So first one is R1 minus R3. First one is R1 minus R3. R1 minus R3 means Y1 minus, this is R3. So Y1 minus Y3 minus 3Y1. So it will be minus 2Y1 minus Y3. Then R2, this is R2. R2 minus R3. So it is Y2 by 2 minus 4Y1 minus Y3. And similarly, R4 minus 2R3. R4 is Y4 plus Y1 minus 2 times R3, right? Minus 2 times R3 means Y2 minus 2Y1. If you do these calculations, so third row is unchanged. Third row is Y3 plus 3Y1, but fourth row will becomes 2Y1 plus Y1, 3Y1 minus Y2 plus Y4. Is it now row reduced echelon form or what? Yes, this is the row reduced echelon form. So uh, this thing, this actually so there, let me copy this. So if you successively apply those operations, then it will actually becomes this, maybe some smaller. So it will becomes this row reduced echelon form, and this last component will be like this. So from here, what you can say that if solution of those matrix exists, that is x equal to 0, x equal to y, this gives the solutions. Then what
3y1
is
minus
the,
y2 plus y4 is equal to 0.
yes? So the last row, you can see the last row of the left side is 0, but last row of the right side is non-zero. So it is not possible because 0 times x1 plus 0 times x2 plus 0 times x3, 0 times x4 plus 0 times x5, this cannot be same as 3y1 minus y2 plus y4 equal, this cannot be same as this until this
Plus
combination
0.
is 0.
Yes.
Therefore the combination is 3y1 minus y2 plus, so we can write 3y1 minus y2 plus y4 equal to 0, which is same as y2 is same as minus 3y1 minus y4. So let us see what is the correct answer. So question number 5, it is actually B. Y2 equal to 9y1 plus 2y3 minus y4. So I think there is some mistake. There is some calculation mistakes. So first one should be minus 2y and y3. It is okay. Actually, there is small mistakes. It is y2 y2. It is okay. Minus, there should be minus y3 minus 4y1. It is also okay. Second one, y3 plus 3y1. This is okay. Actually, I have done some mistake. You can check. I am not checking again.
Sir, I am
But
getting sir 2y3 plus 3y1 minus y4 minus y2 is equal to 0, sir.
yes.
Sir, I am not getting sir 9, sir. Please show the option, sir.
Okay, okay. So let me write the correct thing. This should be actually y4 minus 9y1 plus y2 minus 2y3. So you can check the row reduction will give you this. I have done a mistake in the fourth, in the computation of this fourth
Sir,
row.
sir, y1 should be sir 3.
Y1
Coefficients,
should,
sir, coefficients of y1 should be sir 3 minus 3.
coefficient of y1 is 3. Where?
Yes, sir. Sir, I am getting this, sir.
You should get -9, right?
Sir, let us perform this, sir, again.
Okay, let me perform this. So where the R4 is changed, you can see R4 is changed here. R4 plus 2R1. This is R4, and 2R1 means Y2 minus 2Y1. So Y2 minus 2Y1. So let me write Y2 minus 2Y1, and you have added this with Y4 minus Y1, which will give you Y2 plus Y4. So there should be some y2 plus y4 minus 3y1. So there is a small mistake. After that, we are doing r1 minus r3. So sorry, r4 minus, this is now r4. R4 is now,
Sir, this will become minus, sir, y2 minus 3y1 plus y4.
so this is r4 minus
Yes, sir.
2r3. 2r3 means 2y3 minus 6y1. So if you do this, you will get minus y2, sorry, uh, y y2, then y4, then minus 3y1 plus 6y1, which is 3y1, then minus 2y3. Is it? So it should be y2 plus y4 plus 3y1. Okay, plus 3y1. So this is what you get, right?
Yes, sir.
Okay. So I think I need to change this. So there it should be y4 plus 3y1 plus y2 minus 2y3.
2y3. Yes, sir. Yeah.
So the correct thing will be
2y3 is equal to y4 plus 3y1 plus y2.
yes. Correct thing is y2 is equal to 2y3 minus y4 minus 3y1. Right.
Yes,
So
sir.
let me copy it. If you put, can you check if it is matching with something? It is not actually matching. I have done any mistake also there also.
Sir, I am also getting, sir, this. You have written y2 is equal to 2y3 minus y4 minus 3y1.
You are getting this, but
Yeah, yes, sir.
it should be that, because I have checked earlier. It was previously matching with this answer.
Sir, you can write, sir, again this matrix, sir, and again perform the row operations.
Uh,
So let us do it again, sir.
okay, for now let us keep, but later we'll come back,
Okay, sir.
because the process is clear, right? You need to form an augmented matrix and perform row reduction such that it becomes row reduced echelon form.
Yes, sir.
So if row reduced echelon form is, you have got that row reduced echelon form. If you notice that left side contains 0 but the right side contains some non-zero things, then this should be 0. Actually this is the same thing. Sorry, it is clear, right?
Yes, sir.
Okay. So question number 6. W1 is given by this, and W2 is another subspace of 2 by 2 matrices. So there are two subspaces of all 2 by 2 matrices. Okay. So the question is, what is the dimension of W1, W2? Do you know what is the dimension? What is the meaning of dimension? So
Yes, sir.
dimension of vector space V, it means So any vector space V can be written as linear combinations of basis elements. Okay. So dimension of V can be written as linear combination or linear span of some elements alpha 1, alpha 2 up to something, some n. Okay, and if those things, suppose it can be written as alpha 1 up to alpha n, and if those n elements are also linearly independent, then we'll say dimension of the vector space V is same as n. Okay, so if V can be written as linear combinations of alpha 1 up to alpha n, and moreover those entries are linearly independent, this is also needed, then dimension of that vector space is denoted by n. For example, can you say what is the dimension of set of all 2 by 2 matrices?
4.
It is 4. Why? Because any matrix A, B, C, D, you can write it as
3
A
times
times
1,
1, 0,
0,
0,
0.
0 plus B times 0, 1, 0, 0, C times 0, 0, 1, 0 plus D times 0, 0, 0, 1. Okay, so any matrix can be written as span of those four matrices. Any matrix belongs to span of those 4 matrices. Moreover, those are linearly independent. Since if combination of those things is 0, this will means those A, B, C, D, those 4 things will be 0, right? So those are linearly independent. Linearly
Sir, option
independent.
sir, option C should be correct.
Okay, so here option C. Let us see if it is true or not. So let us check. So for our question, W1 is defined to be this. W1 is defined as x1, x2, x3, x minus x3. So you can write W1 as x1 times 1, 0
0, 0.
plus x2 times
0, 1, 0, 0.
plus x3 times 0,
0,
0, 1
1
minus 1.
minus 1.
So now you cannot write as those combinations. Why? Because you can see this matrix 0, 0, 1, 0, this actually does not belongs to this W1. That's why I cannot write as combination of those kind of matrices. Okay. So where the condition is x x1, x2, x3, those are from R. So from here you can see that since those 3 matrices are linearly independent, okay, you can check that if this combination equal to 0, this will automatically imply that x1, x2, x3 minus x3 equal to 0, which will imply 0 matrix means all entries are 0. This x1 is 0, x2 is 0, x3 is 0. Right? Therefore, these 3 matrices are linearly independent. So those are linearly independent and spanning the vector space. From here, what can you say? You can say that dimension of
Dimension of
W1,
W1 is 3.
this is actually 3. So this is actually wrong. Now by the same reason, you can write W2. This W2 can be written as Y1 times
1001.
1001 plus Y2 times
0110.
0110. Okay. So here Yi again belongs to R. So from here, the same check will give you two linearly independent matrix which is spanning spanning this W2, right? Therefore, again, the dimension of W2 cannot be 3 because there are only two matrices in this spanning set which are linearly independent. So this is dimension of W2 is 3. So this is false. Now, what is the dimension of the intersection? So let me write, copy this thing. Paste. Okay. Now, what is W1 intersection W2? So let this x1, x2, x3, x4, this belongs to W1 intersection W2. What is the meaning? So this means this matrix will also lies inside this W1, right? But what is this W1? W1 satisfies the conditions. Uh, this fourth entry x4, this should be same as minus of x1, right? So if a equal to this, since a belongs to W1, this will imply x1, or we may write x4 is same as minus x1, right? Again, a belongs to W2. A belongs to W2, what will be the implication? Here you can see that first entry and fourth entry are equal. Okay, so it will imply x1 equal to x4, and also second and third entries are equal. X2, x3 are equal. Therefore, x2 equal to x3. So from here, so x4 equal to minus x1, but x4 equal to also x1. Is it possible? When will it be possible? So you can
x4
see,
0, x1 0.
yes, from 1 and 2, 1 comma 2, what we are getting? X4 equal to minus x1, but again x4 equal to x1, so it will be x1 equal to x4 from here, so it will be minus x4. This implies x1 equal to 0, sorry, x4 equal to 0, but x4 equal to 0, again by 1 we are getting x1 equal to 0. So therefore all such matrices can be written as x1 is 0, x4 is 0, and also x2 and x3 are equal. So there is x, there is another x, right? This is clear, right? So those are all possibilities. From here, you can see that W3, intersection W1 intersection W2, it will look like this, where x belongs to real number, which is same as x time the reverse diagonal, right? It is same as x time 0, 1, 1, 0. So there is only one linearly independent vector, which is generating that vector space W1 intersection W2. Therefore, this is the correct answer. Dimension of intersection is 1. Okay. Question number 7. Which of the following statements is correct? Is or are? Let us see if something. Any superset of a linearly independent set is linearly independent. Is it true? So for 1, you can, for example, let us consider R2. So 1, 0 and 0, 1, these two
So
are
this is
linearly
false.
independent.
This is false.
This is obviously false, because if you add another 1 comma 1, it can be written as, suppose this is E1, this is E2. It can be written as E1 plus E2, which is, so there is a relation between A. If you choose this is as S, and if you include this 1 comma 1, so S union 1 comma 1, this is not linearly independent. This is not linearly independent because there is some relation. Therefore, this is false. Now for option 2.
Sir, this is correct.
Any set which contains linearly dependent set is linearly which contains, so suppose T is linearly dependent. So T is linearly dependent means suppose uh, T is alpha, maybe instead of alpha 1 let us denote it by some row 1, row 2, row 3. Okay, suppose T is like this and there is, those are linearly dependent. Those are linearly dependent means C1 row 1 there is some relation Ci row I, summation of this is 0. If you add any other thing, so if you take T union another T dash, then this relation is also present in T union T dash.
Sir, some Ci non-zero, sir. One more
Yes,
condition
it is.
for T.
Yeah, thanks for the corrections. For some Ci non-zero, that is there exists at least one I for which Ci is non-zero.
Sir, for some Ci non-zero.
Yes, for some there exists Ci's for which Ci is non-zero. Okay, so you can see for T union T dash, if you take another such R row 4, row 5, those type of things, then there is this relation is also present there, right? Therefore, any bigger set will be automatically linearly dependent. So this is true. The third option is any set which contains a zero vector is linearly independent. Is it true?
No, sir.
Because if 0 is there, 0 can be written as linear combinations.
A0 is equal to 0, some non-zero.
Yes.
For any A non-zero, A0 is equal to 0.
Yes. So if 0 is there, for example, 0 comma 0 vector comma 1 0, right? If this is there, then you can write this 0 first element. Suppose this is alpha 1, this is alpha 2. Alpha 1 can be written as 0 times alpha 2, right? So you are getting 1 times alpha 1 equal to 0. You are getting a non-trivial linear combinations which gives you a 0. Similarly, if only 0 is there, suppose only 0 is there, then you are getting these combinations. 1 times, suppose this is alpha 1, then you are getting 1 times alpha 1 equal to 0. So again you are getting a non-trivial combination. So this is also false, because a non-trivial combination is giving you 0. That means those are linearly dependent. Any subset of linearly dependent set is linearly dependent.
Sir,
So
by
again, this is
option A, sir, by option 1, option 4 is false.
by option 1.
By example, sir. By example, in option 1, option 4 is
Yes,
false.
by the same example, you can see that S union 1 comma 1, this is linearly dependent, but its subset S which is independent. So this is also false. Question number 8. Here V is R3 and B is an ordered basis of this vector space R3. Then the question is, what is the representation of this 6 comma 2 comma 6 basis, that is coordinate with
Coordinate
respect to
vector.
this basis.
Yes, sir.
So let us solve this. So the first step will be like this. So you are trying to suppose this is alpha 1, this is alpha 2, and this is alpha 3. So this is the basis. We are writing basis equal to alpha 1, alpha 2, alpha 3. So those are ordered bases. You cannot change, rearrange those bases. Otherwise, you will get wrong answer. Now the question is 6 comma 2 comma 6. Suppose this is, instead of writing, suppose this is actually B. So the question is, can you write B as some combination of, maybe write in this way, some x1 times alpha 1 plus x2 times alpha 2 plus x3 times alpha 3. This gives you this B. Can you write? So what is the meaning of this? This means,
Sir, option C.
okay, let us solve if it is option C or not. So x1 times 1 0 minus 1, x2 times 1 2 1, x3 times 0 minus 3 comma 2. So this is same as B. B means 2 0 2. But if you compare those components, the corresponding to the first component 2, what relations are you getting? You are getting x1 plus x2 plus 0x3 equal to 2. Similarly, the other relations are 0x1 plus 2x2 minus 3x3 equal to 0. Similarly, others.
Sir, sir, we are writing, sir, 6 comma 2 comma 6 as a linear combination of
Yes,
elements of B, sir. You
exactly.
have written the 2 comma
So
0 comma 2.
this problem, if you write those three equations, you will get the same thing. That is, we are trying to write 6 comma 2 comma 6 as linear combinations of those vectors 1 0 minus 1, 1 2 1, 0 minus 3 2. Right? This is, so the following question is equivalent to solving this system. A times x equal to this B.
Yes,
Maybe
sir.
this is B transpose in this case. Right? So we need to solve this. What is
Sir,
the
sir, in the
process
right
of
hand
solving?
side, sir, in the right hand side of this equation, you have written 2 comma 0 comma 2. So this should be 6 comma 2 comma 6.
6 comma 2 comma 6. What is the 1 2 1 0 minus 3 2? What is the problem in this case?
Sir, we want to, sir, find the, sir, coordinate vector of 6 comma 2 comma 6. So we will, sir, write 6 comma 2 comma 6 as a linear combination of the
Yes.
elements of B.
So from here you may directly write, but I will again do those previous type of things. That is, try to reduce it further. Okay. You
So,
can,
sir, you are taking this, sir, option, sir, directly, sir. 2 comma
yes.
0 comma 2 is option A, sir.
Yes, 2 comma 0 comma 2 you can discard by options, but let me show the procedure how to solve general problems. So you will get another equations equal to, but let me solve in general way. So again we'll perform the row operation. So it will be R3 plus R1, third plus, so first one is 1106, 02 minus 3 2, and if you add R3 plus R1 it will be 0 2 2, and this thing will be 6 plus 6, which is 12. Now I'll exchange those two rows. Okay, and another thing is half times R3. Half times R3 will give you 0 1 1 6. I'm not writing those above rows. Next again we'll change R2 R3. Exchanging those two rows, it will give you 0 1 1 6, 0 2 minus 3 2 1 1 0 6, right? So you can perform R1 minus R2 and this R3 minus 2R1. You will get 1 0 minus 1 0 here, and you are getting 0 1 1 6. It is unchanged, but the second one will be 0 0 minus 3 minus 2, which is minus 5, and 2 minus 6, sorry, 2 minus 12 minus 10. Now the second will be apply this R3 1 by 5 times R3. So I am directly writing this will be minus 1 and this will be minus 2. And again subtract, so cancel those ones, right? So you need to perform this operation R1 plus R3 and similarly R2 minus R3. If you apply this, you are getting 1 0 0. So R1 plus R3, it means there will be minus 2, and 0 1 0, R2 minus R3, which is 6 plus 2, which is 8, 0 0 1 minus 2. So the answer will be minus 2 8 minus 2. Oh, I have done some mistakes. What is happening?
Sir, option C should be, sir, correct.
Yes, you are right. Option C should be correct. Let me just check it. So first one is 6 to 6. Then there will be 6 to 12. Then 6 6 minus 10.
Sir, last row, sir. R3 minus 2R1, sir.
R3 minus?
2R1.
Here I have made mistake.
Sir, minus 3, sir. There should be, sir, minus 3 instead of 5.
Instead of 5, there is minus 3.
Minus 3.
There is minus 5 minus 10. It should be there. Up to this, I think everything is right. 0 1 1 0 6. Let me
So
just
from here, sir, you get, sir, 2, na, sir?
Yes. Oh, here it will be 2 because I am dividing by minus 5. Sorry.
Yes, sir.
So it is 2. That's why
Now
my
it will be,
mistake.
sir, okay.
Now just calculate. You will get 6 2 1 2. 2 4 2,
2,
right?
4, 2. Yes, sir.
Yes. Okay. So 2 4 2 is the right answer because this means Ax equal to B. I am reducing to row echelon form, which is identity times x equal to something. Okay. So what is the meaning of identity x? I am just applying row echelon. I am applying some elementary operations. It means p times ax. I am getting this is same as p times x. But you can see pa becomes identity, right? So I am getting identity times x equal to px. Therefore, p must be inverse of. Sorry, uh, this was b. Earlier, this is b. So p must be inverse of that thing, right? Identity times x. I am getting identity times x, which is x, which is pb. Therefore, p must be inverse of a, right? So x is a inverse b. So this is the solution. So 242 is the correct answer. 242. This is the correct answer. Always note that ordered basis means if you write in the coordinate form, then it should be in the column vector 242. This is the correct, but not uh, row, any row. 242, if that row is given, that is not true. Okay, question number 9. Let us solve this. So here two bases of R3 is given. One basis is that standard basis E1, E2, E3, but second basis is something else. Those are two bases of R3. Now we are writing ABC as coordinate of ABC with respect to basis 1 and coordinate of ABC with respect to basis 2. Then question is, x can be written as x1, that coordinate can be written as p times x2. Then what is the value of p inverse? So let us solve this. So ABC, again by the same procedure, ABC can be written as, and you can easily see that ABC, this is same as a times 100 plus b times 010 plus c times 001. From here it is clear that ABC, coordinate of ABC with respect to beta 1, basis 1, this is same as those coefficient ABC, right? Now the tricky part is, again we need to calculate coordinate with respect to this basis. So the same type of calculations. So we'll put those things in column, right? So let me put
Sir,
here.
sir, please show this a question, sir, please.
Yes.
Question, sir.
Okay. So
Wait, sir, please. I want to write the question.
1 to 1, 0 minus 3 2. You need to write ABC
Yes,
as
sir.
linear combination of this. So I am again I have constructed augmented matrix. Okay. So I want to express ABC as linear combination of this thing. This is equivalent to solving the equation Ax equal to this B, ABC, which is B, right? Transpose of this thing. So I am trying to solve this equation. So again, we'll apply row reduction. So first process is R3 plus R1. 110A, 02 minus 3B. This is 02 and 2C plus A. Now half of R3. This will give you 011 C plus A by 2, and everything is same. 110A, 02 minus 3B. Now R1 minus R3, and first better to exchange those two rows. R2 3 R2 3 are exchanged, then we are getting 011 C plus A by 2, 02 minus 3B, and above is 110A. Then R1 minus R2 and R3 minus 2R2. If you apply this, you are getting 10, which is 0 minus 1, which is minus 1. Then A minus this, which is A minus C by 2. Then it is A plus C by 2. I have just rearranged. Then 0, 2 minus 2, which is 0. Then minus 3 minus 2, which is minus 5. And B minus this, which is 2B minus A minus C by 2. Again, do this operation, which is same as, so you can do this operation 1 by 5 times R3, so that leading entry becomes 1. So I am not performing this operation. So 1 by 5, the next operation will be, next operation will be 1 by 5 times R3, which will give you, minus 1 by 5, which will give you 1 here, and minus 1 by 10. Right? Minus of this. Now it is almost done. We need to do this operation R2. So just rewriting this will give you a plus c minus 2b by 10. Now R2 minus R3, and first R1 plus R3 and R2 minus R3. This will cancel those two things. So this becomes identity matrix 1 0 0 0 1 0 0 0 1. But the last becomes R1 plus R3, that is this plus this, which is a minus c by 2 plus a plus c minus 2b. A plus c minus 2b by 10. And similarly, just a minute. Okay. So I am getting this here, and the second thing is R2 minus R3, that is a plus c by 2 minus a plus c minus 2b by 10, and a plus c minus 2b. Oh, I have done some mistake. C plus a minus b by 5. There should be c plus. What is that? Okay, so can you just see where is my mistake? Can you see the mistake? So let me again try from the first step. It is given like this. I am applying R3 plus R1. This is R3 plus row 1. So it will give you 0, 2, 0, 2, 2, and a plus c. It is okay. Now half of R3, half of this, it is giving you 0, 1, 1, c plus a by 2. Okay. Then exchanging those two things, 0, 1, 1, c plus a by 2 and 0, 2 minus 3 b. It is okay. Now R1 minus R2, that is this minus this. So you'll get 1, 0, minus 1. It is okay. A minus, that is a minus c by 2. It is okay. And R3 minus 2 R2. R3 means 0, 2, 2, 0, and minus 3 minus 2, which is, let me write that step instead of and doing mistakes. So it will be 0, and next thing will be 0, minus 3 minus 2, which is minus 5, and b minus this, right? B minus 2 times c plus a, which is again 2 will get cancelled, so b minus c minus a, right? Okay, if this is clear now, instead of doing this, so 1 by 5 times R3, everything is same. Last row is 0, 0, minus 1 by 5, 0, 0, 1, and a plus c minus b by 5, because we have divided by. Next step will be just to cancel this 1 and this minus 1, what we'll do, we'll apply this r1 plus r3, so that we are getting 1 0 0 here. Okay, and we'll also get a minus c by 2, a minus c by 2 plus b minus c minus a. And similarly it is 0 1 0 because I am applying this operation r2 plus this is actually this because I have applied, so it is a plus c minus b by 5. And second one is r2 plus this, right, r2 minus r3, so one get cancelled, it will become r2 means it is a plus c by 2 there. So oh, some glitches, a plus c by 2 minus r3 means this is the r3 corresponding element, a plus c minus b by 5, and this is again a plus c minus b by 5. So this is 0 0 1. So I am getting this I comma something is, what is the calculation will be 10 bar 10 and above will be something like this 5a minus 5c, so 7a minus 5c plus 2c minus 3c minus 2b minus 3c. And similarly this is equal to this identity comma, this is 3 by 3 identity matrix, and again if you add those things 3a plus 2b plus 3c by 10, and the last thing will be c plus a minus b means a minus b plus c by 5. Actually it is unchanged, this is actually divided by symbol, maybe for uniformness. Okay, so from here you can see that the matrix representation, sorry, the coordinate of ABC with respect to basis 2, ABC with respect to basis 2, because I have started with basis 2, it will look like this 7a minus 2b minus 3c by 10, 3a plus 2b plus 3c by 10, a minus b plus c by 5, right? This is the metric representation with respect to B2. So according to the question, metric representation with respect to B1 is x1 and with respect to B2 is x2. So this was x1 and whatever we got, this is actually x2. And moreover, x1 can be written as px2. Then what is the value of p inverse? So here you can see that x1 is written as px2. Therefore, p inverse x1 equal to x2. But note that x2, this x2 can be written as this x2. This is same as ABC times the, if you write the coefficient, first one will be 7 by 10, then minus 2 by 10, then the third one will be minus 3 by 10. Similarly, 3 by 10, 2 by 10, and 3 by 10. Apply the same procedure, 1 by 5 minus 1 by 5 plus 1 by 5. So x2 can be written as this, but note this was x1, right? This was x1 equal to that matrix. So from here it is clear that x2 equal to p inverse x1, but this is actually x1, this ABC. From here it is clear that this is actually p inverse, right? So this should be the correct answer. Let me paste here. So check what is the correct answer. Last entry is 1 by 5 minus 1 by 5. So 1 by 5 minus 1 by 5, 1 by 5. So those two are discarded. 3 by 10 minus 1 by 5. Again it is plus. So this should be the correct answer, D. Is it clear? The procedure? Okay. So again, let me repeat what we have done. So first one will be just represent this ABC with respect to basis 1, which is this ABC. It is clear because it can be written as A times 100 B times. It is clear that's why it will look like this column matrix or column vector ABC. Similarly, we are trying to represent this ABC as linear combination of with respect to those basis element. This. So this is equivalent to solving those. So I put those basis element in column. Those are the basis element, and I am putting ABC in the column. So we need to solve this equation. A times x equal to b. A times x equal to b. B is that ABC, right? So to solve this, again we are performing those row operations and trying to make it in row echelon form. From row echelon form, it is clear that this side is identity and this side is now those entries. So from here we are getting the solution is this. Therefore, ABC, the basis coordinate of ABC with respect to this basis will be same as this. But from the question, it is actually x2. But you can see that x2 can be written as product of this. X2 can be written as something of this form times ABC. It is also clear, right? Just do the multiplication. 7 by 10, you are getting this. So if you got this from here, it is clear that P inverse must be this because x2 is same as P inverse times x1. But x1 we have already arrived that x1 is ABC, right? So this is the correct answer. Now let us consider this problem. Here V is vector space of all function from real number to complex number. V equal to functions space consisting the function of this form, real to complex. And moreover, this is a vector space over complex polynomial. It is also clear because any function, if any function is given, just multiply with some complex number. C times fx, this is defined by C times fx, C into fx.
Sir,
So
over
this,
complex polynomial, sir, this should be complex number. What is
yes,
the sir field? Sir, you have
over
written complex.
complex number. Sorry, a small mistake. This is a vector space over complex numbers, and there are two different set of function. One set is f1x equal to 1, f2x equal to e to the power ix, and f3x equal to e to the power minus ix. And another set is 1 cos x sin x. So the question is, those Gj can be written as linear combination of f1, f2, f3. Then what is the value of this matrix Pij? The matrix obtained by Pij, that is P is Pij. Okay, so let me write the solution. So you can see that G1x equal to 1, which is same as 1 times f1x plus 0 times f2x plus 0 times f3x. Similarly, G2x, so this is actually, if you compare with this, from here it is clear that this is actually P 1 1, this is P 2 1, this is P 3 1, right? Similarly, G2x, which is same as cos x, you know that cos x is same as e to the power ix plus e to the power minus ix by 2. So from here you can write this as 0 times f1x plus half times e to the power ix. E to the power ix actually f2. So half times f2 plus half times f3x. Now similarly g3x, which is say sin x, e to the power ix minus e to the power minus ix by 2y. If you write this, you are getting this is same as 0 times f1x plus 1 by 2y times f2x plus 1 by 2y times f3x. Right? So from here, so those are our entries. Those are actually P. This is 2, so it will be P1 2. This is P2 2. This is P2 3. Similarly, J is fixed. Sorry, 3 2. The second thing is fixed. J is fixed, only I is varying. So 1 3, P2 3, P3 3. Those are the coefficients. So if you write P as this matrix P1 1, P1 2, P1 3, P2 1, P2 2, P2 3, P3 1, P3 2, P3 3, you can see that 1 1 2 1 3 1, from the first thing, first equation, it will give you the first row, first column. Similarly, 0 half half, if you put the values 0 half and half. Similarly 0 1 by 2y, 1 by 2y, minus, sorry, there is some minus sign. Okay, minus 1 by 2y. So this should be the correct answer. A is correct. Half minus half. Okay, this option is actually not there. 1 by 2y. So this is the correct answer. This option, though this is not there, this is the correct answer. None of the above. Maybe include this. Option D, none of the above. Is it clear? This is actually called matrix representation. So there is three vector. Those three vector are representation, and this can be written as linear combination of those vectors, and the matrix formed by those coefficient. This is called actually matrix representations. Is there any doubt?
No, sir.
Okay. If not, let me try to correct the last question number 5. There I got something wrong. So again we are applying those row operations. First one is this R2 minus 2 R1. This is this R3 plus 3 R1. This is okay. R4 minus R1 is also okay. Half of R2. This is same as y half of Y2 minus Y1. Okay. Okay. So R4 plus 2 R1. R4 is now this Y4 minus Y1, and this is Y2 minus 2Y1. So R4 minus R4 plus 2 R1, right? R4 plus 2 R1. So if you add this thing, that is Y2 minus 2Y1, then minus 3Y, it is also correct. After that, what happened? R4 minus 2 R3. This is R4 minus 2 R3. Sorry, this is this minus 2 R3. 2 times R3 means 2Y3, 6Y1. 2Y3, 6Y1 will be deleted, subtracted, minus 2Y3 minus 6Y1. If you subtract from this, what are you getting? Yes, it will becomes 9. Yes, yes, that is fair. Now I think it will be correct. So if you subtract this, you will get minus 9Y1 and Y2 minus, so there is Y2, and after that it is Y3 is not there, so minus 2Y3 and plus Y4. Plus Y4. Yes, so the correct answer will be like this. The relation, this is same as left side is 0. Just this was 0, 0, 0, 0, corresponding thing. And this was 0, 0, 1, 0. Okay. So that was the matrix. Oh, what is happening? Okay. So from here, comparing this, we obtain that minus 9Y1 plus Y2 minus 2Y3 plus Y4 is 0. From here, you can see 9Y1 is maybe Y2. Y2 is same as 9Y1 plus 2Y3 minus Y4. Yes, so this is the correct answer. Okay. Now it is fine. So we got the correct answer.
Sir, I have a sir question, sir.
Yes. Any
Sir,
question?
yes, sir.
Yes.
Sir, can you write the question, sir?
Which question?
Sir, not from this, sir.
Not from.
Not from these slides, sir.
Okay.
Sir, from the question is about row space and column space.
Row space and column space. Okay.
Yes.
What are you
Sir,
asking?
if A comma B comma C belongs to M real matrix of n cross n.
Those are m by n,
Yeah,
n
yes,
by
sir.
n real matrices.
Yes, sir. Such that A is equal to BC.
A equal to BC.
Yes, sir. Sir, then, sir, row space of A is subset of row space of C.
Row space of A. This is subset of row
Row
space of
space of
C.
C.
True.
And column space of A is subset of column space of B.
Yes, true.
Yes, sir. Sir, how, sir? How, sir?
How is it true? Okay. Let
Yes,
me
yes.
explain. So A can be written as B comma C. Okay. So what is B comma C? Maybe you can write
B
C
into C,
as,
sir.
if you write C, so B comma C, if you write C as those column vectors C1, C2, Cn, from here you can see this was earlier A. So from here you can see that it is same as C1. Okay. So let us only consider let us see the any column. Take any column, B times Cj, right? So what is B times Cj? Let us only pick, for example, let us pick B times C2. What is B times C2? C2 will be look.
C2,
C2 is
sir,
of this form, right? For
n
example,
cross 1. N cross
example,
1.
yes. For example, if you do 1, 2, 3 up to some n, for example, let us consider this thing. 1, 1, everything is 1, last entry is n.
Sir, BC2 will be, sir, second column of A, sir.
BC2 is second column
Second.
of A.
Yes,
Yes,
sir.
this is second column of A. But can you see BC2 can be written as linear combination of columns of B? Suppose C2 is like this. Suppose mm, my eraser actually not working properly. Okay, so suppose this C2, suppose C2 is C2 comma maybe 2 comma 1, C2 comma 2 up to C2 comma n, and B is this column vector B1, B2 up to Bn. Then what is B times C2? This is same as C21 comma B1 plus C22 comma B2 plus C2n
Yes, sir. Yes, sir. Sir, clear, sir.
Bn.
Sir,
Right?
what? Yes, sir. Clear. It is, sir. Clear, sir.
Okay. So
Sir,
from here you,
yes, sir. This clearly shows that column of A is subset of column of B, sir.
yes.
Sir, but what about, sir, first one, sir? Row space
First
of
one
A.
is the same. Just do the opposite thing. Instead of writing columns, now write it as rows.
Rows of C. Rows of B, sir.
Yes, rows of B's. So first take rows of B and do the same type of things.
Multiply C, sir, from left side.
Yes,
Yes, sir.
the same thing. That is for BC, put something like this. So it will be now maybe row 1, row 2. Those are rows. rho n times something times c. Now check
Yes,
with
sir.
any row. For example, similarly you can check with row 2 and multiply with that c.
Yes, sir. Okay, sir. Thank you, sir.
Oh, okay, it is a good question. Now let me stop here. So, do you have any question? Any other question? If you have any other question related to these topic, you can ask.
No, sir.
Okay, nice. Ritik, Sandeep, do you have anything to say?
No, sir.
Okay. Okay, so let me stop here. Thank you for joining.
Thank you, sir.
Thank you, sir.
Okay.
Sir,
Yes.
sir, can you make a WhatsApp group, sir? So we can ask sir questions, sir. There.
WhatsApp group, I think there is something like some Google group is there. So
Sir,
you may,
Google. So there are problems, sir, in posting questions, sir.
what is the problem?
Sir, the format, sir.
Uh, Format?
If you type, sir, questions, then some symbols we cannot write, sir, in text
Okay.
message.
Okay, then I'll share my contact number.
Yes,
Can
sir.
you mail me? My
My
email
number,
is
sir.
already there.
Uh, no, sir. Can you post it here, sir?
Okay, I'll post in that Google group. Okay.
Uh, okay, sir.
Okay.
Sir,
Let me show.
thank you, sir.
Okay, thank you.